All right. Hey, everybody. It is the 2nd of August 2023. It's Wednesday. It's 14:30 UTC. We meet twice each week for live coding on Wednesdays and Thursdays. We're going to go on a quick hiatus after this week and be back the week of August 21st. But we got some exciting stuff to look at. I was hoping today we could focus on the PBL faucet project, and we'll get into the reasons why. But before we jump into some explorations there, just wanted to give everybody a chance, if you want to, give us a quick update on what you've been working on and maybe a question that you've had recently. And if you're not sure about a question, maybe just a place that you've gotten stuck recently. Anybody want to chime in? Sebastian, hey.
Hey, hello. So hi everyone. Well, recently I began to go through the material and I was wondering where my PPBL token was, and it turns out it is locked because I didn't finish the web development of Project 202. And I'm stuck there because I'm not very good at web development. I kind of hate it. What I'm trying to do is try to get a block frost request to turn the metadata of a policy ID. I got it so far as to get the request go to block frost, so it is pinged there. I can see it in the dashboard that there is a request, but in the page, the metadata doesn't appear, so I'm stuck in that part.
That's something we might actually organically look at today. That's great. And I did unlock your contributor token last week. I saw that it had been sitting there for a while and that commitment had expired, but I knew that you were working on some other things. And thank you. Like, I think it's really important that people say what parts they like and what parts they don't. If you're not here for front-end development, you're exactly right. You shouldn't get bogged down in that. But if you love front-end development, likewise, say the same thing. Can you check that maybe that token is back in your wallet?
Sure.
Okay.
Well, I mean, it is important to know how it works, even if you don't like to do it.
You know, if you, for anybody in any sort of project manager role or on a team, right? Whether, even if you're just writing the Plutus smart contracts, you have to have a working understanding of what's going on, even if you're not expert.
Yeah, it is there in the wallet.
Okay. And then looking at metadata, we might get to that today or tomorrow as we start to look at the faucet project. And I'll see if there's a spot where we can take a quick look at that together.
Perfect. Thanks.
Who's next?
Go on then, I will. What have I been doing? Playing tic-tac-toe. There's a React course that is shown on, I can't remember which, it's 201 something. If you excuse me, if you click on it, it takes you to a little tic-tac-toe program to build, which I managed to do. Basically, you copy I will say most of the code is there. It didn't always work out exactly the way they put it. And I missed one bit, so it wouldn't work. So I had to go and do a bit of debugging, which was interesting. But I've kind of got a bit of a handle on how React works now. And there are because it's basically uses a TypeScript type development environment. A lot of it has similarities to how Haskell works with types. And you can hand a function to another function as a property. So if you hand some some properties to a function. One of those properties can be a function, which then means that the function that sent the function can get the result back from it, whereas it wouldn't necessarily be able to do that. I think that's right.
Exactly right. TypeScript is optional for React, but there's a growing, overwhelming consensus that you're better off using TypeScript with React than vanilla JavaScript. And the reasons are exactly what Dan, you just said. You know, basically, as we start to use TypeScript, if you've been doing any Plutus or Haskell development, that's going to feel relatively familiar. And TypeScript, it doesn't get us all the way to the place maybe where Haskell is. That's a debate for a different time. But it does get us to a very similar place. And as you're writing smart contracts that have well-defined types, it's pretty easy to translate those types from the Haskell or Plutus environment into your TypeScript environment to make those one-to-one mappings. So that's great. And by the way, just in case we forget, IOG has used their experience of building Cardano, and they're building another blockchain called Midnight. And I don't know when it's going to come out, someday, right? But Midnight, all development is going to be TypeScript native there. And so you can't go wrong learning a little bit of TypeScript right now if you want to be set up for that future interest. Anybody else feel like sharing? No pressure. You don't have to. Any other updates?
I can go, but I've been like saying this like for the past 2 weeks. I mean, I'm still in like 204.3.
Yeah. Good. That's the main event today. Let's do it. That's great. I'm excited to finally get here, Harsha. Anybody else?
I have a really quick one that might be just a mistake that I'm doing that I haven't been able to figure out. I've been trying to do I think it's a 202.4, and I think this has been answered before, but it just kind of crashes when I try to connect my NAMI wallet. I know that I did the assignment, but some reason I can't. It just won't connect. It just I'll get it. I'll show the error message right now. When I try to connect NAMI, of course now it's connecting. Maybe.
Classic. Do you want to do a quick screen share on that?
Yeah. Let me see if I can make the error message.
It's really funny.
Make it crash. When you're ready to commit. This profile. This might not be the correct wallet. Can you see my screen?
Yep.
Okay. Let me just check that it's the wallet that has a token. It's not. Yeah. Two. Okay. What about if I try to connect the eternal one? I know like that one has the token.
I don't know how robust the automatic disconnect is. You might have to refresh the page and then try connecting Eternal again.
Okay. I might have to enable the app connector.
Yeah. I see it. I see the Eternal extension up there in your browser.
Oh yeah. It's on the other side. I missed it completely.
We don't want
Where
main.
is
Yeah.
Yeah, true.
Because just going to eternal.io is not going to help anyway. We need the browser extension to have the dApp connector functionality.
True. And I need to tell what wallet I need anyways. Let's go. I need to do some transferring. Okay, let's just check that this one has that. Here. Okay, yeah, it's here.
Yeah. Good.
So PBL and paternal. Oh yeah, connect the site, of course. Switch to the Eternal browser extension and activate a DApp account. It is activated. Okay, I'll just refresh it again. Let me try again. French. Eternal. Think here. Why is it telling me to switch to the Eternal and activate a DApp account? This is activated.
In the settings there, so that looks good, but in the settings, are there any settings we have to change?
Currency transactions.
Maybe on the wallet side, you see how there's the other settings in the top center?
Oh, correct. Yes.
I forget if there's something here. One of the things I'm not sure about is if there's any sort of collisions when you have multiple wallet extensions in the same browser. Have you had success connecting before with the multiple?
I was just using Nami. I've never really used Eternal before. It might very well be.
Check that. Yeah, you might have to jump to.
Okay, so this is why is this?
Oh, that says
main
mainnet. Yeah.
Pre-prod here.
Roberto,
Yes.
close the Eternal window in your browser and then click on the browser extension. I think you're looking at it through the browser, not through the extension.
There you go. Okay. This is probably going to say it's on mainnet, maybe.
Let's check. Oh, and it's hadn't updated either. Okay,
Nice.
Pre-prod. Keep down. Well, connect. I haven't seen this new things. P2P.
Yeah, the Eternal team is on fire right now. It's really awesome. So yeah, they're not loaded into this browser. Oh, there they are. Okay. Okay.
It's just on 0. I heard this happened. Let's just see if I have the token available. Not yet. Oh, it's importing, syncing. Yeah. It's just taking its time. Cool. Okay. Again, let's try this again. So this is Nami. Cool. Now, Eternal. Now let's see if it's showing up on pre-prod. Yes. Okay. Cool.
Nice.
Perfect. This is exactly what happened.
Excellent. Okay, and what does the console show us?
I'll show. It's the resolve payment.
Wouldn't resolve payment, right?
It's bigger. I don't know if you can see there.
That's on assignment 202.1.
Yes.
Interesting.
Minting tokens. I kind of don't remember right now really well, but it has something to do with it read the wallet, the issuer wallet, and then my wallet differently.
I'm just trying to see if I can quickly recreate the same error over here before going a little deeper into it. Oh, right. We have the multiple checks happening. Yeah. Okay. Why are you getting that?
You can see the QQRC So you can see the different queries and what it grabbed.
Right.
And so you have this QQRC is mine. And then there's the test WR6, which I think is the
That's
issuer.
that's the contributor reference address where we can see some data.
And you can get, and it gets a token.
Mhm.
But then I don't think when it tries to check against mine, I don't know if it doesn't find it, or this is one token and this is, no, sorry, this is not the one for this. So the policy ID that we're looking for is this one, which is this one on my address, which
Mhm.
matches the address of the reference one.
Mhm.
So, and the output of the transaction is QQRC. This is mine. Token. Okay,
Down
and
below,
the
once again, what does the error say? Once again, sorry, I was just navigating to this page
no
all the
problem.
way down
Oh, the error here.
in the console, yeah.
Resolve payment key hash. Couldn't
From
resolve
that
payment key
address.
hash.
Oh, yeah, because that is a contract address. Okay. There's probably a good reason why this is happening. Well, there's always a good reason. And give me 1 second to I want to make a quick decision here about whether this is a 3-hour detour or a 6-minute detour. And then if it's the latter, we'll keep going. But let me take a quick look over here. That's happening. Frameworks.
But Roberto,
Yes.
did you have the Eternal wallet set up for multiple addresses to start with, and then you changed it to one address?
No. It was just. Oh, how do you mean multiple addresses? Like multiple accounts for one address?
Eternal will generate multiple addresses, whereas Nami uses one address for your wallet.
Not sure. How can I check wallet settings?
Yeah, it'll be in there.
Custom receive address set. Internal mistake.
I can't remember where the setting is, but I know I had an issue where I couldn't get Eternal to connect.
So one thing that might help with that is that I had this error initially on my NAMI wallet. So I was just using NAMI. This is like the first time I've ever used Eternal with the Plutus PBL. And the only reason is, for some reason, because I think this is the same address. No, it's not.
This
Yeah.
this is happening at the end of the day. Can you go back to that error for us?
Yes.
And if you scroll down, you see where it says couldn't resolve payment key hash from this address. And it's the same address every time. It's the one that ends in FEO7.
Correct.
Can you copy that address and bring it over to Cardano Scan pre-prod?
Yeah.
And what we're going to see here, notice at the very top of the page, this is a contract address. Contract addresses don't have pub key hashes. They weren't generated that way. Okay. And it's not your fault that this is happening. The reason this is happening is because of a lazy but purposeful implementation in the front end. That's basically looking at a set of addresses and it's making assumptions about which one is which. And the assumption it's making is delivering to it this contract address instead of your connected address. Okay. And so this is the difference in the JavaScript code or the TypeScript code between, saying, okay, we got a list of items and I'm pretty sure the one I need is position 2 in that list versus filtering the list for the one we actually want.
Okay.
And the filtering would be a better option. Let me add a fix there, and let's do a live demo of how to fix that at the start of live coding tomorrow.
Perfect. Okay.
Yeah, that'll be more efficient. It would kind of take up the rest of our time to kind of go through that live right now and talk through all the implications. I want to have a really short and sweet solution for you tomorrow.
Sounds good. Okay. I'll stop sharing then. Thank you.
Cool. And actually, this really does get us into where we're at in this course. Okay, so everything in the first 2 modules is built to expose us to as much as possible, right? And kind of the gotchas and the troubleshooting along the way are part of that. But what we're moving towards is a more robust understanding of how applications can work when we start to put these pieces together. And I want to show an example of that. And what's cool is that there's a bunch of different puzzle pieces are going to be connected here. So the page that Roberto was just looking at, I could see it right here, and it's working for this particular wallet. And what we're going to lead off with tomorrow is we're going to look at how to improve this, how to make it a little bit more robust, because it's not good enough right now. And this is always going to be the case, right? So much of what we have to do when we build the front end of an application is take some data that we query from the blockchain. Ideally, the query is well written and gives us only what we need. But even when we get only the information we need, we're still going to have to filter it in certain ways, okay, to make sure that we're getting, for example, Roberto's wallet address instead of some contract address. And with this upcoming, there's a few other implications to this. I want to look for just a moment at the contributor list right here. There's data here. Some of this data comes from on-chain, but not all of it. The survey completion stuff at the bottom, this is not on-chain data. This is just human updated data from a Google form. Okay. But in the top row, this is on-chain data, right? We can see how many people have minted a contributor token. We can see how many people have mastered different modules. And this is kind of an interesting query that we're going to look at in at the 300 level, when we start going a little deeper into indexers. And we can even see on-chain how many people have changed their lucky number. And lo and behold, 128 plus 26, yeah, good, that's 154. Right? Everybody who holds a PPBL token has either changed their lucky number or they haven't. Cool. We also, once people make commitments, it shows up on this route right here. And maybe you've seen this, maybe you haven't. This is it's a placeholder, and it's not meant yet to be a beautiful interface. It's really just meant to kind of reveal to us what we have here. But all of it's just on-chain information. There are common functions we can use to grab this information. And this might take us back into what Sebastian was saying earlier. I want to look at how to grab metadata for any NFT, okay? And we talked about Block Frost as one option. I want to show you a general purpose way to do that by the end of this lesson using GraphQL. But we have all these different tools for querying data and getting it. But at the end of the day, look at this right here. We can see that Faizan has a commitment. Rahat has a commitment. And hey, guys, it's good to have you both here. Rahat, welcome. And I have a commitment here. Okay. And I just merged or approved their merge requests this morning. And these are both ready to be distributed. We could do it from right here. But at the very same time, and you can see this is the live deployment, we're working on a more general purpose version of this application right now. And you can see this is running on my local host right now. But notice down here, this is the same information we were just looking at on the other interface. And one of the key concepts we're trying to teach in this course is the concept of a headless application. All of this data is on chain. I could look at it like this. I could look at it like this, or I could look at it some other way. However we want to style it. Neither of these are production ready yet. This one looks a little bit more kind of like what people expect out of a generic website. This is just some crazy PPBL stuff sitting here. And if we were going to build this dApp for production, we might have different expectations for what should be on the page, but the information is all here. We can come back. I think by the end of tomorrow, we can come back and look at what it means to distribute these things. And this is going to be exciting because this is 2 more people who have completed module 204. And as we've talked in the past, the goal is to get 12 people across that finish line. This is going to bring us to 8 out of 12. Nice. We only need 4 more people to finish module 204 now before we open up the next part of the course. Awesome. So let's take a close look at module 204. We want to understand a little bit more about how this thing works. It's mostly provided in documentation so far. There's a very short introductory video, right? Well, it's 10 minutes. That's relatively short for this course. So we have the intro video right here, just encouraging you to get started. And then a series of steps that, if you've understood everything in the course so far, should be doable. Step 1, right? You're just going to compile a validator. You're not actually writing any new Plutus code, but there's this concept of a parameterized smart contract. And essentially, this is a very, very important concept, but you can take a look for yourself. There's some code in the Plutus template repo that you don't have to change. Okay. Source. Faucet mini project is here. And this validation code, which we're going to come back to in just a minute, never needs to be changed. The only thing that needs to be changed is this compiler right here. And what parameters allow us to do is reuse the same logic over and over again. The same validation logic over and over again, but with different parameters. And if you only change one thing, the policy ID of the token you are distributing, you'll get a completely different contract address. Let me pause there. So at a high level, this concept of parameterized smart contracts, who's got questions about that? Whether you've already been through this project or you're seeing it for the first time.
So I've always wondered, I know that like parameterized smart contracts are, it creates an instance every time you change the contract, as opposed to you can either hard code it, you can make it parameterized. I think there's another way of doing it. And I was
So yeah,
yeah.
this is great. So, right, we've got these parameters here. Faucet params have there's two fields in this record, an access token symbol. This is the one we're just looking at, right? You saw this in your wallet, Roberto. Everybody's got their PPBL token with this, and then some faucet token symbol. Yes, these could be hard coded, okay? Instead of writing a validator that had parameters here, we could delete the parameters from this signature, and we wouldn't any longer have FP coming in right here. And we could just hard code those values somewhere like here or here. Yep. And we could write a non-parameterized version of this same contract where these two values were just hard coded. Now, at the end of the day, for you, if you are opening up this project, running it in a REPL and compiling by changing something here, it actually doesn't save you much time, whether the change you need to make is right here, or if that change was just to a hard-coded value in this validator. Where the efficiency comes from is there are other ways to supply these parameters. Okay, so in late 2022, we demonstrated how to just provide an endpoint that anybody can hit. They can provide their own parameters for a ready-to-go contract, and they can compile on demand an instance of it. That's where things start to get really interesting. But for now, you're just seeing how these patterns work inside of a Plutus TX project. So what is the logic? Now let's take a look at this. This contract validates if a few things are true. Okay. And maybe you've seen different patterns for how validators are written. Different people have gone different distances into Plutus TX. So if you've gone deep, hopefully this makes a lot of sense to you. If you're still just getting started, the purpose of this overview right now is just to help you start to think about how Plutus validators work, okay? And you might have seen some examples where we put our conditions, our trace if false statements at the top of the validator. And this is demonstrating the other pattern where we can put them at the bottom. We say, let all this stuff be present in these 5 checks. What are the things we're checking for? We're checking that input has an access token. That's just a function that's written up here. It returns a Boolean. It could be true or false. And that's true of all these things. Input has access token, returns true or false. Output has access token. Same thing. Output has faucet token. There it is. Faucet contract gets remaining tokens. Yep, that's a Boolean as well. And finally, check datum is a Boolean. Along the way, there's some other helper functions we might want to use. But the pattern here, right, we say, look, hey, if this thing is false, return an error message, right? If it's true, and we validate. So input has access token. It's true if the access token symbol in FP, what was FP? FP, it's defined up here. Oh, that was our faucet params. Okay. Does FP have something called an access token symbol in it? Yeah, it sure does. Oh, good. There's my, okay, access token symbol. That's coming from those params that we defined at compile time. So if that symbol is an element of all tokens, what's all tokens? All tokens was just defined here. It's a list. You see the square brackets. It's a list of currency symbols. And currency symbol is precisely synonymous with policy ID. They mean the exact same thing. All right, you'll call it a policy ID if you're talking about the NFTs in your wallet or what you're looking at on a blockchain explorer. In Plutus TX, they're called currency symbols. So all tokens uses a built-in function called symbols to give us a list of all the policy IDs in this transaction. And we just want to return true when we confirm that the access token, the PPBL token, is one of the policy IDs represented in the inputs, right? The value spent, inputs are spent, right, to this transaction. Not going to go that far into like the details. This is here for you to learn from, to kind of start parsing this logic. But just to give quick treatment to the rest of these functions, right? We saw output has access token. It's similar, right? Let's make sure that we're sending to the receiver that access token. We're sending it back, okay? There should be one or more. The case where there's more than one is actually not something we'd want. We would really prefer that this is equal to exactly one, but this is included here just to allow for troubleshooting and playing around a little bit. And the cases where somebody might have minted multiple tokens and they're locked in the same UTXO. Does the output have the faucet token? What was the faucet token? Okay, the sender's got to receive those faucet tokens. The logic here looks pretty much the same. There's some built-in Plutus functions in play right here, but we're also looking for not the access token symbol and name, but this time the faucet token symbol that comes from the same place. Oh, yeah, this faucet token symbol. This is the one that when you do the project, you're changing this policy ID to the policy ID of some token you've minted. And when somebody hits your faucet, they should get some number of those tokens. How many should they get? This is going to be equal to a withdrawal amount. Where does it come from? Well, it comes from the datum. Where's the datum defined? Oh, right here in our validator itself. What kind of datum is it? It's a faucet datum. Where was that defined? Faucet datum was imported from types right here. Let's take a look at those as well. All right, so we've got the validator open. We've seen the compiler and how we can change that. Types are now right here. And what we're looking for, the faucet datum. And this datum defines a withdrawal amount. Now, could this withdrawal amount just as well be placed in the parameters? What if I took this line right here, line 27, and I just moved it up to the faucet parameters? then I would just have to add a line in my compiler file. I would just add that withdrawal amount, and I would specify a number at compile time. Every time somebody hits this faucet, they can have 99 tokens. And 100% that would work, right? And instead of saying withdrawal amount datum, we would say withdrawal amount FP. So far, so good. Why remove this from the parameters and place it in datum? Anybody got ideas about that?
Is it to limit the number of tokens? If it's in the datum, they can't change it. But if it was in the parameters, you could say anything.
Ooh. You're on the right track, and it's exactly the opposite, actually.
Oh,
Check it out. If I compile a contract with a value in the parameters, and I derive a contract address, right, from this validator with these parameters, now anytime I want to withdraw tokens from that contract forevermore, I can only withdraw that amount. But datum is different. And this is starting to move us, Harsha, to the pain point of funding a treasury. When is datum defined? It's defined when you actually put the tokens in the treasury in the first place. The good news is, though, if we look in datum for this information, it could be changed. I could lock a UTXO at my contract address with datum that says, hey, from this UTXO, you can withdraw 25 of my tokens at a time. But then I could lock a different one, same contract address, but I could lock it with slightly different datum that says, hey, but from this UTXO, you can unlock 99 tokens at a time. And so datum, actually, this is the part that allows us to put some data on chain that might be changeable. Contract params, once compiled, can't be changed. Datum can be changed without changing the contract address. And we're going to look at how to add that data in just a minute, okay? But keep that in mind. And remember, datum is attached to the UTXO itself. What do you think? So we have this dynamic ability. This doesn't help us see where this number actually comes from. It's easy to find the access token symbol. It's in my params, and I had to define those in that compiler. Datum, the definition of datum, or the specifying of what it is right now, is actually an off-chain action. Okay, so if you've heard the terms on-chain and off-chain, this validator here, this is what people are talking about as on-chain code. Okay, all of this, at the end of the day, everything in this validator here is encoded in a contract address, and it's what we have to validate against every time we want to unlock from that address. But the precise values of this datum, those are defined off-chain. And we'll see that in just a minute. Does the faucet contract get the remaining tokens. That's down here. But if you compare this line, output has faucet token, to this one, faucet contract gets remaining tokens, you'll see some things are similar. Okay. We're going to take from the number of tokens that were in the faucet, we're going to subtract this amount right here, the withdrawal amount in the datum. And the amount that the contract gets back has to be greater than or equal to what we expect. Right? You can't return fewer than, you can't, the treasury can't have, if I'm only allowing somebody to withdraw 100 tokens at a time, the faucet couldn't get back what it had minus 150, for example. And notice that this right here, value of faucet output value, this looks kind of similar to value to receiver. And then finally, we check the datum. Check datum. And all this is doing, long story short, is it's making sure that the datum doesn't change. Okay, once you add a UTXO to your contract address, somebody who's withdrawing from it must build a transaction where the datum is exactly the same as it was before. If they try to change it, the transaction will fail. This, in the off-chain part, in the front-end part, this part is going to be invisible in this case. It's not always invisible. Sometimes you want people changing datum, and we're going to see a lot of examples of that, especially as we look a little bit more about how these commitments and distributions work. But in some cases, there's no reason for datum to change. So you add this to your validator, and then the task of your front end, the task of your UI, when somebody builds a transaction, is just to make sure that the same datum was supplied. Okay. But to the end user, it's going to end up being invisible. How's this feel to look at Plutus TX like this? We're going to keep spiraling. I've talked about the word scaffolding as an education concept. Spiraling is another one. It's imagine yourself going around a whirlpool, down and down and down into the deepest, deepest knowledge, right? And every time you go around, you get a little closer. A few more things make sense each time. And that's our goal here, right? Is to use examples like this and little by little build up understanding. And so I hope that this wasn't too alienating a pass through this validator, and we're going to have chances to keep looking at it. To make it make more sense, let's now jump back to the project. Okay. So the instructions here just say, okay, we'll go to that repo we were just looking at. You can open it on your computer or on Demeter Run. Open that compiler file that we were just looking at and change the token symbol. And this is the extent of what you'll use a local Plutus development environment for. I recognize that some people are still working on getting NICs set up. But Demeter offers an option and it works there. And this is the only thing we need to do with Plutus for this project, right? Compile this once. If it does load successfully, we load up that compiler. And then we use this function name, write faucet validator script. Let's look at that compiler again. No, these are our types. Let's go back to the compiler. Right. This compiler has a function called write faucet validator script. And it has a path to the file that it's going to create. So anybody who successfully ran this step right here is going to see that new Plutus file in their output directory. Why? Simply because that's what was defined right here. All right, that's step one. Now there's a few more steps that happen. Reference scripts are another new concept, right? Instead of just needing to pass around the Plutus script, we can place our CBOR hex basically on chain. And this is what we mean by reference scripts. And the word deploy has kind of emerged as people have recognized that's what you're doing. Okay. When we first had the Vassal hard fork at the end of 2022, it wasn't kind of common to say that this is what it meant to deploy your contract, but it started to be the way people have talked about these things. Okay. Okay. Is your contract deployed? Yes. I wrote it onto chain as a reference script. At the end of the day, right? Everything you need to do is provided here. But at the end of the day, you're going to have a transaction hash and a transaction index of your new reference UTXO. And when it comes time to troubleshoot, we'll have some time to look at this. But for now, this is the key thing to understand. Okay. And I hope if people get stuck on this step, we can come back and look closely at this one. But this is a really big idea. Harsh, you didn't get stuck here, right? This part went okay? Good. Okay. Then, so our Plutus script is on chain. If I'm using Cardano CLI at this point, I actually don't need the Plutus script again. Unfortunately, some of our off-chain systems are still being built. And so we do still need that Plutus script, as you've seen at the end of the project, step 6. You got to add the CBOR to the repo. And I'll show you why that's the case. There are actually some alternatives to that. But for now, this is where we're starting. Okay. Step 3. Should we go deep into this step? Harsha, this is the one that's getting hung up.
Yeah, the transaction build part.
Would you be willing to take the reins here and demonstrate how far you're getting, and we could try to troubleshoot?
Yeah, give me 2 minutes. I'll start
tell me when you're ready.
Demeter. Yeah.
Cool. All right, so we've got our contract address. That's where we're going to send these tokens. We've got a reference script on chain. We're not actually going to use it until step 4 when we unlock these tokens. But before we can unlock any tokens, of course, we got to lock them in the first place. Okay. Now zooming out, we just looked at the validator code. Let's look for just a moment at what the front end looks like. Okay. So this is the end result of our work. Uh-oh, there's an application error. We saw this. Somebody mentioned this in Discord yesterday. Shrey saw this. Okay. So why is this happening? Well, there's a few things that could be going on. Check the browser console. Let's see if it tells us anything good. Cannot read properties of undefined. That feels reasonable. Okay, but where, right? And so let me just show you for just a moment what might be happening here. And in order to do this, I'm going to run this project locally so we can try to troubleshoot it. So I'm going to use the same path, just with localhost 3000. Oh, ready yet? Oh, I don't need the HTTPS problem. Let's try that. Here we go. Okay. And so we're getting a different error here, but because I'm in dev mode now, it's a little bit more helpful. And let's jump in to where the data is in the first place. So in the PPBL front-end template, we have source, Cardano, faucet mini project, and then this one JSON file right here, where anybody who's finished the project has added a key, their contract address, and a value, the CBOR for that contract. And we can see, oh, we got a squiggly red line here. I bet that's where the problem is coming from, right? Why is that there? It says expected comma. Let's go to the end of the previous line. And you can see that these should be comma separated values, right? And there's a comma missing on line 11. Let's add that. Save. And it didn't solve the error for me yet, but at least I got a different error. Let's see what happens if I refresh that. All right, now it's working. Okay, so that error was really just happening because of a comma. And end result, this is ugly on purpose. Why? Because we want to encourage people to start thinking about, oops, I turned off this server, so I can't find that anymore. Never mind. We want to give you really ugly versions of stuff so that you're not afraid to try to make them prettier. Okay. Anybody who likes UI design, front-end design, you could have all sorts of fun with this. But obviously we want this to be very obviously not production ready. And so I hope it's garish enough to prove that point. But it does have some cool stuff. It shows you, oops, if I connect a wallet, it shows you some nice information. So as you start to get into a little bit more about, okay, redeemers, how can those be represented? Here's an example of how a redeemer is represented in Mesh. Here's an example of how a UTXO, well, two UTXOs, the input and the output, are represented in Mesh. Here's the reference UTXO that we put on chain. Here's the current datum. And by the way, in this case, how many tokens? This is our withdraw amount right here. And here's some metadata. Okay. And the goal would be, if this works, I haven't tested this one yet. This is the newest one. I think this is Faizan's. Let's try it. Okay. If I have a PPBL token in this wallet, I should be able to get one of these nice new faucet tokens with this policy ID that I have no control over. Let's see if it works. Okay. Yeah, sure. I'll confirm. Okay. NAMI pops up, prompting for a signature. I like to know the details. This is pulling from the contract address. And it's going to send 998 tokens back. Look, there were 999 there. If I get one, my front end should send the rest back. There it is. That's good. And what do I get? I just lose my fee and I get a faucet token, one of them. Cool. All right, but just because the transaction builds doesn't mean everything is working. Let's see. See if it actually works. All right, it did. Faizan, congratulations. If you're out there, he's catching up later. All right, he's done. He's built background knowledge and is ready to keep going. And we could do the same check for Rahat as well. Down here. All right, and we could go through the rest of this list. Now, ideally, there's some troubleshooting to do on some of these because that, squashing bugs is a good way to figure stuff out. But we'll get to that. First, let's do some troubleshooting on the locking tokens transaction. Harshi, you ready?
Yep.
All right, I'm going to stop sharing.
So this is the transaction build for locking the tokens. Transaction N would be any transaction with enough Lovelaces, I would think. Transaction in tokens would be the UTXO with the tokens in it. So this is one part that I had a question on. Tokens to faucet and tokens back to issuer. Can tokens back to issuer be 0, or does it have to be more than 0?
Yes, actually, that's a wonderful question, and it can be 0. And I recommend everybody trying this. Like,
Okay.
you could write whatever policy ID you want in the output. If you put a 0, it'll just be ignored.
Okay. And path to the datum file is the path to datum file, which I put here.
You prepared that.
The S key is S key. Faucet asset is like the whole asset, right? Like with the policy ID and the asset name.
Yes.
And this is the address that would be sending back the change. I think I have all of the variables. And I will copy the transaction build.
Okay, so what's our error say?
It says unexpected slash.
Yes.
I tried it a couple of times removing this one. So it says unexpected slash in the transaction out. So I tried.
There's a couple of them in here just because this was originally in the bash script.
Oh, okay.
Okay. And so on line 176,
Mm-hmm.
you've got right after the plus, the first plus sign, that slash, that's used in a bash script. It's called an escape character that allows us to actually print a quotation mark, right? Instead of specifying a string. So we got to get rid of that one after asset, and then give the same treatment to line 178. And let's see if that's sufficient to fix everything. Oh, good. We just need protocol JSON. And leave this open, random text, but let's look at the actual script that's provided with the lesson.
Script provided with the list.
Okay. Lock tokens at faucet address. Yeah, that's the one. Okay. So I'm pumped. I would do the same thing you're doing, and I'm so glad you're trying to do this by hand, even though the script is provided, because I don't like using somebody else's scripts. I don't feel like I learn enough from them. But also, it's good to get used to reading the script as docs, right? And maybe even to trusting it enough to use it. So what was we didn't have protocol JSON, right? Because that should be, where is that done? Hold on, say if you're look in the, oh, well, it's already in the scripts directory. Maybe that's why. One way to do this is you can just navigate to the scripts directory and run the same command. The other is download that protocol JSON file fresh. Just in case it's changed, which it likely has.
Run the protocol .json as in copy it and put it somewhere.
No, do this. Look in, I forget what file it's in. Can you check in query tip.sh? It's halfway down your menu right now, right under the protocol JSON file.
Okay.
No, that doesn't do it. Check variables private. This gives us that. Sometimes we've been providing just the direct download. Let's just do it from here then. So the command for getting the protocol JSON file, which you're going to see in a lot of pre-written scripts, because it's always good just to download it again. It doesn't cost much to do it, right? Cardano CLI.
Is there a dash or did I just put
That's
a
correct.
random?
Yeah,
Okay.
you got it. And then it's space query space protocol dash parameters. Space specify the network. So in this case, we got testnet magic 1. So dash dash testnet magic. With a dash in between. Yeah, you got it. And then finally, we could actually just run this command and it would print the parameters to our screen. We don't want that. We want a file called protocol.json. So space dash dash out dash file. And this can be used in almost every Cardano CLI command, right? A lot of these will print to our screen, and like query UTXOs does this as well, right? But if you add an out file tag to querying UTXOs, you'll get a pretty nice file that has more details in it than appear on your screen, which is pretty cool. But we know that we want to have a file called protocol.json, so that's what we should call this. Great. And now you can run this command again for your transaction build. It was up there in random. You got it open in the random.txt tab already. Yeah, I think this is going to work this time. Beautiful.
So the quick question, can I not just like copy the protocol JSON file that I already had here and maybe like paste it?
Maybe I'm not. The reason I had you open up a few other files is I wasn't sure where that came from, and I can't remember if that protocol JSON file was supplied by the repository or because you pulled it by running one of the other scripts. And the reason I had you grab the latest version of that file is I just wanted to make sure it hasn't changed since if this was supplied with the repo. Sweet. All right, step 3 done. All right, but let's pause right here and leave that on the screen because this is a helpful example to look at. Does anybody have any questions about any parts of this transaction build that we are using to fill up a faucet for the first time? And man, I love Demeter. It's you obviously you've got the Cardano node add-on set up right now. And for anybody who's not aware, right, if you open up a Demeter instance, it gives you a pretty straightforward way to start using the code in any Plutus TX repo. But there's a setting on Demeter that you can also run a node for yourself. So if you're unable to run a node from your own computer, there's a million reasons why you might not be able to do that. Demeter provides one for us, and you can see Harsha using it right here. Beautiful. Hey, what's your contract address?
1 second.
Can we go look at that address on Cardano Scan pre-prod? And is there a transaction that happened just a few minutes ago? There it is. All right, so this is actually your pre-prod wallet, the address that we grabbed right there. But here's the transaction you just made, right? Click on the transaction hash so we can look a little closer at this thing.
Yes.
And let's look at the UTXOs that were produced. You see next to the summary tab, there's the UTXOs tab.
Oh,
Yeah. And it looks like this one, the one that ends in DAG, got your tokens. Can you click on that address? I think that's still, oh, that's a contract address. Good. That is the contract address. Excellent. Excellent. It's got this balance now, 1,000 of your tokens. And go back one page. And you see the little datum circle at the end of that, at the right-hand end of that contract address. That's
oh,
a
this
smart-
one.
That one, yeah. Let's inspect that datum. Okay. So let's compare this to what we were just seeing in the Plutus repo. What was the type of the faucet datum? Well, it had two fields. The first one was a number. Second one looks like some kind of byte string, right?
Mhm.
And I've got this open on my screen over here. Anybody who wants to take a look, you can review this. Right. I'll put this link in the chat just in case anybody needs it. If I could figure out how to open my, there it is. Okay. So I just put in the chat the types we were just looking at. Faucet datum has an integer and a token name. And does this match with the datum that you just built on your end?
I would think so. I'm just
One
gonna
token.
check the token name.
And go
Oh.
to click the bottom that says the button that says
Oh.
hex to text. Yeah. And I think you need one more E on the end,
Oh,
just from copying and pasting. Yeah, there it is.
so I have like a quick question. Can you send ADA to like a contract address, like directly from like a browser wallet, or does it need any extra
Okay.
steps?
This is the biggest gotcha I know in Cardano development right now. Okay. The answer is yes, you absolutely can. And you absolutely shouldn't. Okay. A UTXO at a contract address without datum or the correct kind of datum to interact with that contract can't be unlocked. In other words, there's a built-in way to burn or accidentally burn valuable tokens. It's interesting to consider why it's even possible to do that, right? But that's part of the permissionlessness of this ledger. Anybody can send value to any other address anytime. There's nothing that can stop any of us from sending tokens. Okay. The Gimbal pool wallet address on mainnet gets some random ass shit every once in a while and makes it look like Gimbal pool is holding all these weird NFTs. Okay. Because people are free to send weird tokens there. Right. And so because of that guiding principle, It's possible just to send any value you want to a token, to a contract address as well. Problem is, it's possible to accidentally lock things. And so when we build applications that are locking tokens at a contract address, this is something you want to practice very carefully on a test net before going to mainnet. And you got to make sure that every transaction you're using is always supplying the accurate datum. Okay. And that's why I do recommend using scripts, right? It's what you just did, obviously it worked for us, but there's a likelihood, I could speak absolutely for myself here, and I feel confident saying that all of us are going to do it at one point. I can have the perfect cutting and pasting ready to go, right? To build the transactions I need. Is it likely that I might forget to change the datum variable to the right datum file at the right time when I'm taking that process? Yes, I will. I have forgotten to do that plenty of times, right? And so I have all over Cardano test nets have locked stuff that's irredeemable because of making that mistake, okay? If you write a script, and actually if you look at the script that's provided here, it actually takes care of writing the datum for you. So by testing the script on pre-prod, A, we can make sure that it works over and over again. But B, when we transition it for use on mainnet, we know that that datum part is ready to go. Okay. And whenever you're building front-end interactions, the same is going to be true, right? When you build and test a transaction, you have to make sure that the datum is always going to be included. The good news is that this is really only a problem, or it's really only an unsolvable problem when it comes to initially funding a contract address. Remember that little bit I showed you a few minutes ago in the validator that says the datum must equal the datum, right? That guarantees that we can't unlock from a contract in the first place if we're not relocking something with the exact same datum. So as long as I don't screw up the first step and I get good datum into that contract address, now I can breathe easy, because at least I know that nobody's going to be able to spend from that contract address and relock there if they do anything fishy with my datum. All right, what time is it? We made it through 3 steps with a few minutes to go. That's halfway through the project. Perfect. Outstanding questions at this point?
I got a question.
Yes, sir. Hey.
What if we do not? Just a minute. Like in the validator, we were checking datum equals to datum, the datum we are getting from the transaction and the datum we have already in the contract. If we do not provide that condition, so anyone can redeem the token, right? So we do not provide the condition and then provide the only ADA. So the ADA can be redeemable, right? The only problem will be then the security.
Yes, that's exactly right. Okay, let's take a look at this one more time together. That's a perfect question. So yeah, let's say I just delete this part right here. And I don't check the datum anymore. I could just delete line 85 and I could delete this check, right? These other 4 things, we would still check for them. So still, yeah, people can only withdraw the withdrawal amount. Anybody who makes a withdrawal has to return the rest of the tokens to the contract. all of that logic would still be there, unchanged. But it would be possible. Here's a way that you could exploit this contract if I didn't include this, right? One reason to include this is just because it's likely that you might make a mistake at some point, and you don't want an unforced error to happen. But there's another reason to include this. Let's say that somebody knows what they're doing, right? And sure, yeah, there's a front end here, and people can come look at the front end and they can only do what my front end allows them to do. That's great, right? But this is not the only way to interact with these contracts. The other way to interact with every contract on this page is by using Cardano CLI. And you're going to be shown how to do that in step 4. So anybody, a lot of people here have already done step 4. If you haven't done it yet, you'll be guided through how to unlock tokens via Cardano CLI. And if you know how to use this, imagine this scenario. I could build an accurate withdrawal transaction, withdrawing the amount that was specified in the original datum, but I could sneak a little detail in there. I could add different datum that allows me, for example, to take all of the remaining tokens in that UTXO.
Right.
Right.
Yeah.
And then, so it would take me 2 transactions. It would take me the first transaction where I made an honest withdrawal and changed the datum, and then a second transaction where now I use my datum to take all the tokens that are left. And we can guarantee, right? There's enough people who know how to use Cardano CLI that if you leave a security hole like that, somebody's going to find it. What do you think?
It's better to always use data than to risk it.
I would recommend always making sure that you have comprehensive datum checks. Yeah, if datum is doing anything important in your application, you should make sure to include full control over when that datum can be changed. But this is where it gets really interesting. Is it okay if we go like 2 minutes over today? Can I leave you with one more thing to think about today? Because we're on this datum thing.
Yeah.
I want to throw one more thing at everybody while we're here. So let's go to the front end template itself. Here it is. All right. So this is the actual website. A lot of you have made commitments to it. This is the one we're actually using in the course. And this, you can see it actually failed because of that missing comma. So I got to push the change with the comma we just added, and it'll be working again. We might find there's other errors there after we do that, but we'll save that for tomorrow. But if I go into, actually, this is not what we should be looking at. Everybody here, if you've changed your lucky number, you've already interacted with a smart contract, right? You've used what we're calling the contributor reference contract. And that's over here, I think. Contrib token, okay? And some people might have seen this before, but let's just take a quick look right here because we have some really interesting distinctions here. This has nested let statements, right? The faucet project has just one giant let statement, and at the end, it has one final in statement. This one's different, okay? This says, let all of these things be true in a set of cases. And here's 3 different cases. 1, 2, 3. And inside of each of those cases, we have another let statement. Well, if this is the case, let this be true in this. If this is the case, let this be true in that. And if this is the case, actually, that one's simple. Only admins can remove contributors, right? And this is a backdoor. I wouldn't want to have a backdoor like this on like a DEX, because it means the makers of the DEX would have a lot of power that maybe they shouldn't have. But for this course and for the ability to clean things up, right? For example, right, Rahat, you asked about like removing an extra token earlier today. This is the backdoor that allows me to do that in this case. Okay, so I wouldn't want to include this in a production level application, but when we're testing things, it's nice to be able to undo stuff when we're playing around. Okay. These are the 2 cases that really matter. What are the 2 things that can happen to your contributor datum? Well, either you can complete a new module and get it added to your list. And every time you make a commitment and it gets distributed, you get the module you just completed is now on chain. You've done that. Or if you're doing the change your lucky number assignment, you can update the number. So check it out. Who can update the number? The contributor can. Who can update the completed modules? Only the admin can. What this means in general is that you can very specifically define, depending on what role somebody has in an application. Not only, it doesn't have to be just like simple, like, can you or can't you update the datum? Instead, what we're showing right here is different roles can update different parts of the datum. If I'm the admin, the new datum must have the same lucky number. Because if I'm the admin, the only thing I'm allowed to change is the list of modules. On the other hand, if I'm the contributor, right, and here's check updated datum here, which is one function. Here's a different version of it here, right? This one says that D has to be required datum. What's required datum? That's defined above. Right here. And this one says the lucky number can be whatever number the contributor said they wanted it to be, but they cannot change the completed modules. Whatever the completed modules are in this new datum, they have to be the same as they were in the incoming datum. We've looked at this before at live coding. We will absolutely look at it again, spiraling. All right, I'm going to keep making this make a little bit more sense each time. But this is one of the critical concepts. That's why I wanted to just share this at the end of this lecture, just because it's a cool spot to get to. And I want everybody to start thinking about what kind of innovations can you build when different roles have precise abilities to change different fields in your datum. How are people doing with that idea? Does it make any sense? We getting there? So tomorrow, if we pick it up from unlocking on CLI, registering, this is going to take us into metadata. Sebastian, are you able to come back tomorrow to look at metadata together?
Yeah, I'll be here.
Awesome. Yeah, this is where we will get to the metadata part, and we can look at some queries together. And in addition, we'll look at how they work here, but we'll also look at some 721 style queries. And then, yeah, then we'll test these, make sure they work. Maybe we'll find some that don't work. We'll do a little troubleshooting, and that'll be that. Any burning questions before we sign up for today?
No, a quick comment. I might be late tomorrow, but I will join in eventually.
Forgive us if we start a little bit without you. We'll try not to lose you now.
No, that's fine. I can watch the retake. It's just I'm out on the canal we're on. They have a work boat, and you can volunteer on it to go and do some cleaning up of the canal. So I'm out for a day doing some of that.
Great. That's good for the mind and spirit. I like it.
Oh, absolutely, yeah. And it's giving a little bit back to the canal we're on at the moment. Is absolutely brilliant. It's very shallow, but the water is crystal clear, and a lot of that's down to the volunteers that maintain it and look after it.
Cool. All right, enjoy
Anyway.
that, and that's cool.
Will do. Yeah, I mean, I'll hopefully get along to catch the second half of the meeting. Have a good one,
Thanks for
guys.
joining in today. I'm going to add a link to this video directly to module 204 for people in the future as well. So if you're watching this sometime later, I hope this little deep dive helps. And we can always do any of this stuff again. So anytime people have new questions, make sure to drop by Wednesdays, Thursdays, 14:30 UTC. You know where to find us. All right. Have a good one, y'all.